But
Right.
all right, so it is 10:01 and we don't want to keep people any longer. And so I'm going to turn it over to Andy and he's going to get us rolling. But I wanted to thank everybody for joining us today. And we are really happy to have Nick Matthes with us from Illumination Solar Training Systems. And I'm super excited for what he's going to share with us today. And with that, let's get rolling. Thanks, everybody.
Thanks, Gabby. Hi, everybody. I'm Andy McMahon. I'm one of the co-principal investigators of the Create Energy Center, and I will be the host for today's webinar. Um, I am very pleased to introduce our speaker, Nick Matthes, today with Illumination Solar to talk about his hands-on solar training labs that he's developed. But before we get to that, I do have a couple things I would like to mention. And Nick, if you could to the next. Um, so you can later on, you can find this webinar along with any of the other webinars that Create develops, along with lots of other resources on the createenergy.org website. If you're looking for additional resources or if you'd like to watch or share this webinar at a later date. Um, Next one, please. Some things I would like to highlight before we get started. We have some summer workshops coming up in about 6 months out in a variety of locations, actually. Uh, our first one in July will be in the Solar Educators Institute at Madison Area Technical College. We will host one here at Central Carolina Community College in mid-July, the North Carolina STEM Educator Institute. And then again, we will have a solar plus storage workshop in late July at Madison Area Technical College. Uh, Additionally, we have more webinars coming up in the next few months. There'll be a variety of topics related to innovative teaching practices that people have submitted to the Create Center that they would like to share with our community. There's some really amazing ideas and some really amazing labs, lectures, all kinds of resources that people have put together and are willing and are going to present on. So it's a very exciting series we have coming up. That said, I would like to go ahead and get our started with Nick today. So our presenter, Nick Matthes, is a master electrician with a passion for making electricity from sunlight. He's worked in the solar industry in a variety of capacities for the last 18 years, from multi-megawatt systems in commercial and utility settings, all the way to small off-grid systems for remote and tribal communities. He's the creator and CEO of Illumination Solar Training Systems, a company with the mission of expanding access to high-quality, hands-on solar training and reducing barriers to solar careers for students of all backgrounds. As a NABCEP certified PV installation professional and PV system inspector with Wisconsin Master Electrical and Commercial Electrical Inspector's licenses, Nick believes wholeheartedly in the power of solar to create positive change and strives to continually explore what with his students and colleagues alike. Nick, thank you for coming today to present. As you go through your talk, if anyone has any questions, please feel free to type them into the chat. If it's a quick question of a clarifying question or something like that, I might chime in and get Nick to clarify. But even if you have a bigger question that we should discuss at the end, feel free to throw it in the chat, and I will bring those up towards the end so you don't forget what your question is. With that, Nick, I'm going to pass it over to you.
All right. Well, hey, thank you so much, Andy, for the kind words and the nice introduction. And everyone else, thank you so much for making it today. Nice. We got a nice balmy winter day here in Wisconsin. It's actually snowed a bit, so we've got a little bit of white on the ground, which is kind of exciting when the temperature is below freezing to actually have some of that white snow with us. Okay, well, anyways, so yeah, as Andy said, my name is Nick Matthes, and I've been working in the solar industry for quite a long time, and been working in the electrical industry even longer. I got my start in electrical in the mid-90s, and when I got my first taste of solar about 18 years ago, that really just hooked me, and I've been pursuing that like wholeheartedly ever since. And so one of the things that's led me to the development of our mobile solar training labs is a combination of my experience installing solar electric systems, but also following up and fixing solar electric systems that have failed, operating as an owner's representative to help them get third-party inspection on their systems, and really trying to understand like where the problems in solar electric systems happen and how can we prevent that. And really the number one thing there is just good high quality training. And as you all in the community and tech college space can appreciate, having good training modalities for the students to draw them in and get them excited about it is really, the first step. And so anyways, we titled this today's presentation, our mobile solar training labs, and that is with the aim of making technical solar training relevant and accessible. Okay, so this is a bird's eye view of the mobile solar training lab, and we're going to go deeper into it, but I just want to show you a picture right at the outset so you can get an understanding of what we're talking about. So the solar training lab comes with 6 full-size solar modules or solar panels, depending on what vocabulary we want to use, and then 1 A-frame cart. But both sides of the A-frame will have different learning modalities here. So here's a utility interactive solar electric system, and here's a standalone solar electric system. So 1 cart, but 2 different training labs on there. And we'll go into that here as we get deeper into it. So just looking at the broader landscape of solar training, I want to kind of look at what the existing options have been and what drove the motivation for building something that was a bit more mobile. So traditionally, solar electric training for technicians, homeowners, and people just curious about the industry has primarily been on stationary systems. And as some of you in the tech college system may have interacted with, you can have a system at your facilities mounted on the roof, sometimes mounted on the ground, or if anybody's seen the system out at Madison College in Madison, Wisconsin, they've got multiple different mounting structures and inverter electrical interconnections showcased. And so that's phenomenal. That, we can really call the gold standard because students can get such a real world installation competencies and get a good understanding of what they're working on, whether that be the actual solar array and the modules on the roof and that type of mounting structure, or the balance of system equipment, the associated electrical interconnections. Real quick, can you guys see my cursor as I move it around?
Yes.
Okay, perfect. Try not use this as my little fidget spinner. Okay, so what we're looking at then is that's been the primary modality of doing solar training, and this works out really well for those situations and for training students on specific installations. And what we see as kind of limiting nodes with this type of training setup is that we need a physical space where we can mount the equipment, where it can be mounted in place over a period of time, and then also where we are going to need to interconnect with the utilities or get some agreement with the utility to connect to their infrastructure. And with that also comes cost. And like this up in the upper right-hand corner is the last stationary training lab that I built. And just in this one picture alone, we're looking at over $60,000 just of equipment. We get to show a lot of things, but it comes at no small cost as far as space and equipment goes. So A lot of good benefits there, and there can be some pinch points or limiting nodes for depending on what our school or organization's training capabilities are. And so that was one of the prime motivations for developing these mobile solar training systems. So when we look at this mobile system, again, this is another image of that bird's eye view that we just took a minute ago. And then so it's deployable. It takes up a footprint, but it's also temporary. We're able to pack it up at the end of class and move it wherever we need to be, pack it up at the end of the semester, or things like that. And so through countless hours of design and iteration and rebuilding and reconfiguring things, we've got the training lab where everything that's shown here in this picture ends up being able to be packaged up on 2 carts. And these carts are roughly 30 inches wide by about 5.5 or 6.5 feet long if you're using longer solar modules. And so now we've got the whole training lab set up on 2 mobile carts that can be rolled into a broom closet when they're not in use, or if you're sharing a lab space that can be moved around piece by piece. And so you can see we've got everything that fits on the bottom kind of nests in there pretty well. And we'll talk about the different components and what makes that all up. So here, this shows our utility interactive grid-tied system, shows our battery-based system on the other side of the A-frame cart, 6-panel solar array with all the racking that models a roof-mounted racking, solar racking system. And then one of the parts I'm really just most personally excited about is the Solar Professional toolkit that comes along with it. And as putting slides together for today's presentation, I realized that that is one of the areas of the training lab that we don't spend enough time talking about or promoting or building a photo bank of, because our having a well-stocked toolkit is really an integral part of this training lab. As anybody with their lab space can appreciate, that having the tools that you need when you need them is invaluable. So with these mobile solar training labs, the key pillars that Illumination is really approaching this problem with is looking at building solar training that's comprehensive, engaging, that's safe. You see, safety is one of the core concepts that we drill into throughout the different training modalities of this lab. And then having a training lab that's versatile, accessible, and portable. So these were the things that we were looking at as we went to build our training labs here. So when we talk about comprehensive, we're speaking about a few different aspects here. So we've got comprehensive solar training that trains students how to do solar installation. And obviously that's not really, too surprising to people, because that is when we think of that is one of really when people are talking about solar training. That's what we're looking at. How do we become solar installers, or how do we train our students to do solar installations? But then really we can dig deeper into it than just the core installation side of things. There's layers upon layers of different competencies and calculations that we can do in the wiring of systems, in the calculation of how do we size these, and overcurrent protection, wire sizing, and ferrule sizing, and all the different things if we so choose to. And then safety is baked into the system. It's baked into the toolkit, and it gives us a lot of opportunities for showing students where different safety gear is appropriate, and kind of builds that culture of safety around solar installations. And it bakes it into the students' experience with solar when they're talking about building or designing a system. Safety becomes part of the culture, where it's just second nature. And that's really one of the primary goals with these systems, is to get people thinking about safety where it becomes second nature. And then this was originally designed as an introductory solar training system. We call this our foundational lab. So it teaches students on the foundational concepts of solar installation and design and installation. And then what it does, though, it provides a springboard to go deeper into these more advanced topics of solar installation around design. And here we can get really granular with the electrical design and wiring systems, and then also the maintenance. How do we show students how to interact with a live system during routine maintenance? What is some of the required routine upkeep? And again, how we didn't want to demystify the equipment in a safe classroom setting, so students know they're able to identify what is an appropriate level to work to interact with these systems in the real field, in the real world, once they're beyond the classroom setting. And so with the comprehensive theme of this, we're looking at, over on the left-hand side there, showing students physical installation of the solar array. And so this is about an inch wide and a mile deep, right? We can look at just the act of installing solar modules, and that's great. But then what we'll do is within that single task, there's just layers upon layers upon layers of learning competencies that can be taught to the students. And one of the defining features of this mobile solar training lab is that students are using full-size solar modules. These are the same solar panels, solar modules that they would be putting on the roof at their house if they were, to install it on their own, or if you're looking at a commercial setting. These are the same size, same style of solar panels. So we opted for this design so that students can become familiar with handling full-size solar modules. Some of the other training labs that we've looked at have smaller solar modules, which are nice and compact, but they don't give that real world experience of what does it mean when you're handling something that is 60 pounds and just a little bit smaller than a sheet of plywood. And so we can train on those safety competencies and the safety of a classroom and have that baked in. And then we go into the wiring and the electrical test equipment, and then also the solar specific equipment. And so this is one of the aspects of the comprehensive solar professional toolkit that really allows us to get layers upon layers of experience and familiarity to the students. So every training lab comes standard with the Staubli MC4 connector toolkit. Here we are in Barbados. Everybody's very excited about the Staubli kit, but if anybody doesn't know, the Staubli MC4 connectors are those two connectors that come off the back of a solar panel, and they allow the panels to get electrically connected together, but also keep them environmentally sound, keep the moisture out. And so this is a really important part of the training competencies, and students are often not given the access to these tools because they're not inexpensive. They're very high quality tools. But so what that means is sometimes students are kind of boxed out of having the high quality tools. And then what we want to avoid with this training lab is to avoid students from being trained on subpar equipment where, we want to train them right from the beginning. And so having Staubli MC4 toolkit, Fluke multimeters, Klein hand tools, and Klein multimeters is a way of showing students kind of how to do things right from the beginning. And then I got another picture where we show the Solar Pathfinder, which comes standard, which allows the students to learn about shade analysis right from the get-go. And then, so here's a more exploded view of the two sides of the training lab. So this lab can ship fully assembled, but also can be disassembled for students to really dig into the equipment, understand the wiring functionalities, and get to use the torque equipment. Like we have torque screwdrivers and torque wrenches that are supplied with the toolkit. And so a lot of different modalities that can go in here. And here we were doing advanced troubleshooting. We were kind of forced into it in Barbados. And so really good opportunities for learning and always chance to pivot. I got my first experience with solar electric system 18 years ago. I was very fortunate to be working with an electrical firm where we were given exposure to a solar electric system and said, hey, here you have 1 month to build this. And so I was already rather familiar with electrical systems, so that helped demystify it or make it a little less scary, if you will. But then I was given the opportunity to work hand in hand with solar for a month. And what happened for me, and what I've seen countless times with students, is that at the end of your month, in my experience, it was that month, but whether it's a couple of days, a week, or whatever, at the end of that experience with the solar, and all of a sudden you see the equipment operating and just activated by sunlight hitting these inert solar panels sitting on the racking, it just kind of hooked me. And it's really an exciting experience. And so what we've done with this training lab here is given students that like low entry point for that aha moment where they can spend, I generally recommend at least 16 hours, but even up to 32 or 40 hours working on this system, building it, testing, troubleshooting, and getting to really experience the different aspects of the magic of solar electric systems and draw the students into it throughout all the different aspects so that it can really spark that light in them and get them excited about working with these working with solar electric systems. And so here, this bottom right hand, or the right hand side photo here was a community in South Minneapolis where we spent a week building the system. And every one of these students had not touched a solar electric system before. And by the end of the week, everybody was just so excited and just on fire. Everybody wanted to get a job in the solar industry. So we were able to spend a week showing kind of what I call like the magic of solar and how just like demystifying it, but also doing it in a way that's very low barrier to entry. So everybody can interact to the level that they feel comfortable with, they feel safe with. And what we've opted to do is build things on the ground so that it can draw in just about anybody that's in the class, lower the barriers for people to be involved. And then, engaging, there's a lot of different fun activities we can do with it all. And, I'll talk all about this some other time, but one of my favorite activities is when we get this standalone battery-based system operating, we can toast some Pop-Tarts or some sort of snacks in there, and students can really see the electrons doing useful work where we can celebrate with Pop-Tarts at the end or something like that. Microwave popcorn's another really fun way to do it. So just more ways of like drawing students in, making the experience engaging for them. And even here, I guess our four-legged friends can appreciate what we're doing with our solar electricity. So safety, safety is just a paramount importance to myself. It can be a buzzword thrown around or, something that becomes very procedural, filling out safety documentation and just saying, okay, I checked the boxes, everything's safe, we've filled out our paperwork, so nobody's going to get sued or blah, blah, blah. And what I like to use with this lab is to make safety more real for the students and do that in a non-intimidating manner. So you can see this picture in the middle. what we've opted to do is go with a racking system that just sits on the ground, and it's a modeled. I mean, it is a racking system that's built for commercial flat rooftops. It's a very popular product with very high penetration, so it's very realistic to what the students might be seeing in the future. But now what we've done is we've taken this multitude of safety hazards that students should take into consideration with solar electric systems. You've got electrical shock hazards, you've got cut hazards, and physical strain hazards, slips, trips, and falls, and just the plethora of things that we want students to be mindful of when we're working with solar electric systems, and try to kind of like isolate and silo them so that it can be less intimidating for students. So now the students don't have to worry about slipping on a roof or trying to understand what's going on with a harness or a rope attached to your back. They can focus on being on level ground while they're now looking at, okay, how do we handle these solar modules safely? Because twists, sprains, and strains is a very real consideration when we're handling 50 to 60 pound solar panels. And then now we can focus on looking at electrical connections. How do we make safe electrical connections in the solar array without having to worry about falling off the roof? And also, how do we turn the torque wrench, and how do we work with the different aspects of the system? So what primary intention with this system is to give like a good runway for instructors to be able to break down the huge multitude of safety considerations and just take it off in small bite-sized chunks. And it's really exciting to see students that are nervous about even touching a system at the beginning of the week to feel comfortable with taking on most tasks by the end of the week. And so here we could show on the left and the right here, we're showing how we've trained students to use electrically insulated gloves and arc flash gear. Here the fellow is wearing the arc flash helmet and bare sleeves as he's working on a low voltage battery. And here we've got the electrically insulated gloves, arc flash face shield, and flame resistant shirt as he's doing testing in the live 240 volt systems. And so, this was kind of an interesting pivot that we made early on. My first approach for building these labs and delivering them to primarily community colleges and trade unions is, as I said, well, here, we'll provide the equipment and you use your own safety equipment. You use your in-house safety procedures, and then that's your liability. And then me providing you a lab should be less liability on my part, on Illumination's part. And it was really interesting evolution here, because as we talked to different lawyers about how to structure things, they said, well, actually, even if an institution has their own existing safety equipment and safety procedures, we're best off to just provide the best safety equipment that we can possibly, so that we give the institution and the students the best opportunity for success right from the get-go. And so even if Tech College has their own safety equipment and safety program, they can use that to augment the equipment that comes with these training labs, which I totally agree with. After we talked about this with the lawyer, I said, well, that makes sense. I've had electrically insulated gloves on my person for over 20 years, and being able to show other people how to utilize them is a really important part of this all. Okay, keeping our solar training versatile. We understand that there's so many different situations out there for where we need solar training delivered. I can imagine that most of the crowd here today, most of the audience on this Zoom meeting, is in a tech college or community college area or institution where there's some sort of brick and mortar infrastructure in place for being able to deliver solar training. But even then, there's a lot of benefits that can be had from our mobile solar training format. Here, over on the right-hand side here, we can see this was actually in North Carolina last summer, where, man, I'm from Wisconsin, and I've never felt heat like that summer, North Carolina heat. And so really appreciated the fact that we could wheel this training lab into the classroom and do a lot of the exploratory work and a lot of the dissecting of bits and pieces in an air-conditioned place. And then what we would do is roll that back outside, build the solar array in the sun, and then get a good taste of what life is like as a solar installer, where you are exposed to the elements. So we got some versatility there. On the left-hand side, this was taking our training lab out to the Pine Ridge Reservation, where this lab now lives. And they have good facilities for doing training, but it was not available as there was another class already set up in there. So what we do is we roll the lab outside and then just set up underneath a good, nice tree for shade in the middle of the summer and delivered a good hands-on class there. So the ability to pivot, when we talk about the mobility of the solar training lab, it's not just for people that are specifically traveling with it, but just looking at the mobility as being an advantage that can augment training in existing situations. And a perfect example of that here is on the left, which was a training lab that we delivered to the island of St. Kitts down in the Caribbean. And what they did at the college in St. Kitts is they did not even have enough space to build the solar array, much less have a permanent system installed. And so what we ended up doing is we built the solar array right in a piece of their like a part of the yard. You can see it's a pretty steep hill there. And then we ran the cable tray over to the training lab, which we just had on a walkway. And so that was the best option that we had available. And being able, even though it lives at a community college, having that mobility aspect of it really worked out. And here we are again back in South Minneapolis, where we were, in the heart of the city, and there's a very busy parking lot, but we were able to carve out a little corner just behind the dumpsters where we were shielded, and the students had a safe area to work and, reduce some of the barriers or some of the distractions that can happen during class. And another aspect of the versatility that we're baking into the system is the ability to have it as a hands-on, in-person training tool. But then also we've been working with the Earth Center and Central Carolina Community College in building out virtual capabilities. And so the plan with this would be to build a hybrid type of format where you can gain some of those benefits that you would have in a hands-on situation and bring that to the virtual world, where we can scroll through, click on the piece of equipment, and then have that equipment pop up and give us details on it. And then accessible, making solar training accessible means a couple things to us. And really one of the primary motivations of Illumination Solar is to bring solar training to anybody that desires it, anybody that wants it. So we don't want transportation to be a barrier, or the lack of having a permanent building to host your solar training be a barrier. So we've built these so they can travel down to the Caribbean or up to northern Minnesota, just south of Canada. And, making it accessible so that it can expand or shrink to meet a training program's needs. So here we have at Madison College, we built 4 of those for the college to use in their programming. And so now you've got multiple units that can be used in the electrical apprenticeship program or the renewable energy program. And you're not limited by the number of students that you can serve. And fitting in with the the mobile solar training lab, functions is just the portability of it, which we've talked about a bit already, but just the ability to pack up a full-size solar training setup and wheel it right into the back of a Sprinter van or right into the back of a pickup truck, whether it's electric or not, into the back of a U-Haul. Oops, I'm going too far here. Into the back of a U-Haul or a trailer, just being able to take this whole training lab and move it. And, you know, even for bringing it down to the islands here, we were able to, again, it seems parking lots are a common theme in the mobile solar training world that I occupy. And so here we were able to ship the training lab in a crate and just have it dropped right into a parking lot. This would have been in Barbados, I guess, this picture. And then adding to the portability, this would be back in St. Kitts, where there was actually not a secure place in the warehouse or in the classrooms where this equipment would be protected. And so what they did is they actually just wheeled it right into the chancellor's office. And so here we right in, there's the main reception desk. And so being able to take this equipment and move it to where it needs to go has been a real big benefit. We've had institutions where they'll wheel it into a broom closet or an unused classroom and then move it back and forth between classrooms. And my personal favorite example is a community center where they decided to just store it in an unused bathroom. And so they just wheel it into the bathroom and that's where it lives. So it's pretty cool to see that portability being proved out in so many different situations. And so, you know, really being involved in the technical college community for many years, and as actually a graduate of a technical college apprenticeship, electrical apprenticeship program, I've got a really good appreciation for the value that technical colleges and community colleges can offer to students and, you know, our communities as a whole. And what we've been doing with these training labs is try and reduce barriers for technical colleges and community colleges to implement their solar training programs. So some technical colleges and community colleges have existing solar programs where they can utilize these training labs to augment what they have already. And then also for other communities, other colleges that are looking at launching a solar training program, we've designed this mobile solar training lab with the toolkit to be a turnkey solar training program. And so here is a photo that we took this last summer at the Madison College Solar Plus Storage Institute. A lot of happy instructors there. Okay, and so with that, I'd love to dive into another case study or another example of bringing these mobile solar training labs to community college, and we'll use that as our case study. So as you can see, Andy, our moderator today, was responsible for getting the mobile solar training lab down there. And I think Andy can speak a bit to Central Carolina Community College's experience here.
Sure, Nick. Yeah, so I guess for today's conversation, just as important as being a co-principal investigator on the Create Center, I've also taught solar at Central Carolina Community College for about 16 years now. And so, you know, as a solar instructor, you know, I think a lot of what Illumination Solar has built into their training unit it addresses a lot of the concerns and a lot of the needs of technical colleges, right? So, but specifically here, so we at the college, the photograph that you're looking at, in addition to teaching students as regular, you know, coursework, we also do host train the trainer events. And so these folks here in this photograph are all instructors from across the country who are looking to either expand what they do in solar or even just adopt some sort of solar principles into their existing coursework. But what we were able to do with the training unit is really to show them quickly, efficiently, and as Nick said, it able to roll it into the classroom, but expose them to kind of a number of ways that this unit could be used. And we used it as a teaching tool throughout the week. I mean, and to your point about accessibility, as you can see in the photo, one of our folks recently had some sort of ankle surgery, and certainly if we would have had to get on the roof to do this or something like that, it certainly wouldn't have been doable. As a teaching resource for my class, we've been really lucky at the college. We have a lot of rooftop installations that our college has allowed us to install, but not so much. We don't have any of the ground level or ground mount systems. And so typically when we do installations with students, it involves bringing students on a roof. Obviously, it's going to be tough to have more than a handful of students at a time. And so having a system like this on the ground is really helpful for us. Yesterday was my first day of class for this semester, and we rolled it out just to look at when we're looking at system configuration, right? And just having the components laid out in kind of a logical manner. The components are ones you'd see in industry, not to put down any other training units, but again, I've taught for quite a while and seen a number of other training units. One of my issues I've come across with a lot of them over the years is that, frankly, a lot of them just don't even use components you'd see in industry, right, or out in the field. They, for some reason, have these weird inverters that no one's ever heard of, but I guess they got a good price on, or whatever and then also nobody really knows if you need tech support. Nobody knows how to do and so I think Nick, one, using the components that are seen in industry, and two, genuinely knowing how to operate these beyond just kind of being an employee at this huge company that just makes trainers and don't really know how to use them or to maintain them or operate them. It's a huge benefit. And so I could go on, but I will stop. But just say that it's a really helpful tool, and everything you said today, Nick, I would agree with.
Yeah, well, thank you, Andy. I appreciate your input, and it's been a really pleasure working with you on this project as somebody that has existing solar training equipment and has been doing solar training for quite a while, to be able to kind of look at this training format and compare it to the other ones. And one of the things we do really pride on ourselves on is, like, this is a solar training lab that is built by solar professionals to train people on solar, whether they want to get a job in the industry or just understand it more. And the team that we have built up here is a team of people very intimately familiar with solar, because it's a passion. And so then, we bring solar training labs to community organizations, tribal communities, overburdened, underserved communities, CTE programs, along with our tech college and community college partners. And, from our tech college and community college partner bucket here, we've got Ken Walls from Madison College, who's built a lot of solar training labs at his school and can appreciate the time and resources that go into building those, and has the perspective of how this mobile training format can fit into a school's plans. And then one of our community organization members, customers that we've been working with quite a bit, understands the mission beyond just training people how to do solar. He calls them as a catalyst for change, so that we can really uplift people and empower whole communities. And that really fits to the ethos of what we're doing here. And most recently, and actually as a catalyst for launching Illumination Solar, we competed and did quite well in the Department of Energy's American Made Solar Prize. Out of 240 teams, we finished third and got one of those big foam checks as a acknowledgement of the work that we've been doing and are continuing to do with different communities. Okay, and with that, we had about 15 minutes, and so I wanted to open it up for questions. And I don't know, Andy, if you want to run this part of it, or if you've got a bank of
Yeah, absolutely.
questions?
Yeah. So I do. There's a couple in the chat that I'll kind of start from the bottom and work my way up here. So the first one, could you talk just a little bit more about using the trainer for battery storage? I think and it says when people hear about solar plus storage, the first image everybody has is typically a power wall. But those
Yes.
familiar with that platform, it's not very useful for training and technicians, but and whereas the illumination equipment offers a lot more learning opportunities. So could you just speak to that a little bit?
Yeah, absolutely. Thank you. That's a great question. Yeah, and it was a very intentional design decision on the part of these mobile solar training labs. So the Tesla Powerwall or a lot of those other integrated battery storage units that are used commonly in residential systems are phenomenal operating systems, and they've been specifically designed to streamline the installation process. And by doing so, they remove the maximum amount of user interface. And so you could put a Tesla Powerwall, which is one of the most advanced batteries in the world, and to install it, you are literally just running 3 wires to it and terminating those 3 terminal screws. And so not a lot of learning, functions we can pull out of that. So a very specific, intentional design choice that we made here was to use these, the charge controller here, the inverter. Can you still see my cursor?
Yes.
Thank you. Charge controller, battery shunt, battery, all these pieces of equipment are external, and the wiring is run external so that students can get a very good visual of what wires are going where and what they do. It makes Ohm's law like tangible. You can see it and touch Ohm's law with your hands and a voltmeter. And so what we opted to do with this, we call it the foundational trainer, because with the utility interactive equipment and everything laid out and piped and wired, just like the electrons flow, we take that and then add in the standalone trainer, which has no connection to the utility grid. It's not connected like a Tesla Powerwall. Those are really going to give you the foundational electrical aspects of both of those systems so that you can kind of see the whole picture. And actually, one thing we're working on for Madison College is the next step beyond that, which is where you take the synthesis of those two, the hybrid of not grid connected and of grid connected, and you get that grid tie battery backup system, which is more so that Tesla Powerwall or Briggs and Stratton, those types of systems. And so we'll have ones completed to show that training and installation modality, but we wanted to start with the foundations, like learning to do longhand math before using a calculator, if you will.
Thanks, Nick. All right. So there's a question about the virtual systems that you mentioned and just the availability of those, or kind of the status of that.
Yeah, that's a great question. So the availability, so the virtual systems is a concept that actually you helped me envision and co-develop there with you guys. And so we started this. This was like a pilot to see how this could work out and how it can be developed. And so it's on the roadmap to develop, but it's in the very early stages. And so as we are like scaling things up and filling out curriculum in different manners, we'll be integrating more of the virtual aspect into it. But to have something that's a totally virtual training platform, I mean, I would say, we're definitely beyond a year with that, because the core intention with this is to provide the hands-on training that we can get for students. Unless if you have different ideas on accelerating it, Andy.
No, I mean, I think that's right.
We
I think
always can.
it's a work in progress, but I do think you're right. It's really to support what is already there. and just to increase accessibility as well. But it is
Yeah.
the ability to have the hands-on components plus these virtual components for being able to envision things that aren't able to be seen, like the movement of electrons and all these other little things that, again, just connect dots for students. They're important parts of this whole experience. And that actually segues nicely into our next question we had was, is there a training lab manual that comes along with this, Nick? And if so, does it have projects and questions and all of that? So what does that look like?
Yeah, certainly. So we've got a hefty outline of lab procedures, and it is not formatted into a full-on like lab training document. And so that is something that is in progress. What we've done with these so far has been integrating them with community colleges and organizations that have existing solar training programs. And so we've got outline documents and lab procedures to do, but as far as a step by step, that is something we are actively working on.
Great. Let's see. Is this system really designed for students who have never handled a system like this, or is it for some experienced students, or is some experience required on the part of the student before they would be turned loose on something like this?
Yeah, absolutely. So this system was designed with the complete beginner in mind as the primary user of it. And so it is designed between the lab activities and the different safety formats and like the siloing of different procedures with it. It's designed to take somebody that has zero previous experience and zero familiarity or even comfort with these solar electric systems and give them that exposure and guidance so that they can become more familiar and more comfortable with it. And that was the primary motivation. We have found through the years that it actually can work very well for doing training on more advanced topics also. So we got people that are using it for their introductory program and then using it for the next stage, the more advanced program, when we're looking at design, maintenance, and troubleshooting and that type of stuff.
Yeah, that actually segues into another question about just, do you have kind of a list of activities that you feel like are appropriate for this already kind of put together? And then are there readings that would potentially go along? So other supplemental resources.
Yeah, certainly. So yes to the first question. That's all there. And then for reading, we have the different manuals that correlate to the equipment, and that is available and put together as a document. And then as far as like a full on curriculum that can be turned over with the system, we're actively developing that, working with NREL actually. And that's going to be coming out here sometime mid-year. And so really excited about that, because then that'll have the full package. That's the point where it becomes a full turnkey system.
And then I think at this point, the one last question is maybe for some folks the question. How much does this cost, Nick?
Yeah, certainly. So the cost for these systems lands somewhere between $29,000 and $39,000, depending on like the different configurations, what the shipping situation is like, and what the like handover and training ends up being. And so I'd be happy to talk through and provide a customized like quote or plan for anybody that's interested. And yeah, there's a lot of different things we can do with these systems, and happy to work with anybody to, help integrate it any way we can.
Yeah, I'll just say, Nick, I have, as someone who has priced a lot of trainers over the years, in the world of trainers, that is a very fair price.
Yeah, well, thank you, Andy. I do appreciate that input. And, you know, that has been a core driving principle for this project for me when I started it, is to make the best training labs out there that give people the most realistic experiential training, but also keep the cost as low as possible so that it's accessible as far, you know, as far and wide as possible. And looking at some of the comparables, we've been pretty happy that we were able to get the price, you know, this low and actually maintain and exceed like learning objectives.
Yeah, and I guess maybe one last question while we have time is if somebody did want to kind of see one of these things in person and put their hands on it and just, you know, take it for a test drive, you know, are there, you know, should someone just reach out to you and see, kind of then coordinate where they're, I'm sure you have kind of a map of where some of these physically are located, and just kind of what would be the best way of going about that?
Yeah, certainly. That's a really good question. And so there's a few different ways of approaching this. So you can always get a hold of us via email or website. Info@Illumination Solar is the one that comes, you know, that's the easiest first touch there. Illuminationsolar.com gives a little more information on what we've been doing, and we have further resources as far as like spec sheets and things like that. And then a link to our YouTube page, which has a couple of videos that will, about 6 or 7 minute videos that talk a bit about what the journey is all about here and what the training labs can do. And then also, yeah, we don't have a map right now of all the places
Oh,
where
I'm
we
sorry. I
have
meant
these.
you in your head kind of knew where they were located, and you could refer people.
I certainly can. And you've just sparked an idea in my mind about building a map out on the website where we can show where these are, and then maybe even have contact info for, if people don't mind, somebody send an email to Andy and say, hey, I'm in North Carolina. Can I come over and check it out? I think that'd be great. And then the one last thing I would say too is if any of people here have attended the high tech conference, or if that, you know, if that's on your radar, we will have this at the high tech conference the week of July 21st in Minneapolis. And I'm sure you can reach out to, you know, anyone in the Create network and get more information about what the about how to sign up for the high tech conference there. But we'll do a deep dive into the equipment there. And then also that Solar Plus Storage Institute in Madison that you had mentioned earlier.
Yeah, both of those workshops, or all three of those workshops, ultimately, that I mentioned at the very beginning, we have these trainers, and again, they're available and for you to check out.
Yeah.
That is perfect on timing. We have about a few seconds left. I just want to take the time to thank you, thank the Create Center, and then thank everyone else for attending today. This was wonderful. We really appreciate your time, and hope everyone has a great rest of their day. Thank you so much for coming and attending.
And Andy, can I add real quick that the workshops that you've been mentioning are now up on the Create website under workshops and events. So those workshops are now up on the Create website. So,
excellent.
Yep.
That's great.
Yep.
Yeah. Well,
thank you, Nick.
thank you, everybody. Absolutely.
Thanks, everyone.
Yeah. Thanks, everyone. Take care.
Have a great day.
Hi, Colleen.
Thanks, Nick. Great presentation.
Yeah.
Hey, thank you. Good to see you.
Thanks. Have a great day, everybody.
Thank
Thanks.
you.
All right. Well, that was awesome. Thank you, you two. That worked out good.